Hi, welcome to my channel. Today we're going to discuss Sigmoid Activation Function, one of the most commonly used activation functions in early neural network models. The sigmoid function is mathematically defined as f of z equals to 1 over 1 plus e to the power minus j. As you can see from the graph, the sigmoid function smoothly maps any input value into a range between 0 and 1. For very large positive values of z, the output approaches 1, and for very large negative values, the output approaches 0. This smooth S-shaped curve gives us a very useful interpretation. The output of sigmoid function can be treated as a probability, which is why it has been widely used in the binary classification problems. Because the sigmoid function is continuous and differentiable, it allows neural network to be trained using gradient descent, unlike the step activation function. However, sigmoid has some important limitation. One major drawback is the vanishing gradient problem. When the input value is large or very small, the gradient becomes extremely close to zero, which slows down learning, especially in deep network. Another issue is that the sigmoid function is not zero-centered. Its output lies between 0 and 1, which can lead to inefficient weight updates during training. To summarize, the sigmoid activation function is simple, smooth, and useful for probabilistic interpretation, particularly in binary classification. However, due to issues like vanishing gradients and non-zero centered output, it is rarely used in hidden layer of modern deep learning models. Thank you.